Okay, so we're going to try and solve this angle of elevation problem. It's a pretty tricky problem. It is it is one that can be solved more than one way, but we're going to use two ways to do it. We're going to first look at it using trig ratios. So I just wrote up here just this mnemonic device, so Katoa, hopefully you've heard of it. It just allows us to identify our trig ratios very quickly. But let's look at the question. So Jim spotted a bald eagle atop a flagpole at a 60-degree angle. So he saw it from here. And it's at a 60-degree angle of elevation, so he's looking up. Okay, and he then steps back 30 feet to get a better angle for his camera. If Jim's eye level is 6 feet, looks like there should be an S here, is 6 feet, how tall is the pole? All right, well, all right, let's see, maybe I'll make this with a number, make it easier for you. But anyway, so this question is one that is really pretty demanding in terms of like work expectations. So I'm going to try and kind of go through it. So first thing we got to kind of figure out is what do we want to figure out? We want to know how tall this pole is, and so what we can say is, right, we know this distance from here to here is this distance here. So we got this 6 feet here. So how can we figure out the rest of it? So we'll just call it h for height. All right, well, I know that this is 30 feet, and I can kind of see there's these three triangles here, of which I have this one's a right triangle and this big one's a right triangle. So they share some information. So there's some principles in triangles where we can kind of think about proportionality. So there's some proportional relationships that exist here. We're not going to go through those. We're going to just look at the trig process of making sense of this, and then another technique that you can use. So if, for instance, I want to know what the height is, I can begin by looking at this angle and this side, and I can go to my mnemonic device for figuring out which trig ratio I should use, which I have off to the side here: sine function, cosine function, tangent function. So this is the sine, this is the cosine, and this is the tangent. Now these are just the three most prevalent, kind of the ones you see earliest on, but so the sine is just the opposite side over the hypotenuse, the cosine is the adjacent side over the hypotenuse, and the tangent is the opposite over the adjacent. So when looking at this, and I have this angle, I have two sides. Well, in relation to this is the opposite, this is the adjacent, so I can conclude that I can say that the tangent of 60, okay, is going to be equal to h over x. All right, well, I can then kind of think about, and that's for this triangle right here. If I just break this triangle apart, and I know that this is 60, I know this is x, this is h, so this ratio is true. And then if I take the bigger triangle, and when I say the bigger triangle, well, I'm not very good at drawing triangles, so I'll try and do it freehand to the best of my ability. I guess that's where rulers come in handy. So freehand sometimes can be problematic. I'm going to just draw it not to scale, just kind of sketch it. Really it's not to scale anyway, but just to give us a good idea. So the point behind it is I do need some more information, and it's missing from this diagram, so let's add it. This angle here is 30 degrees, so we want to make sure. So if I look at this angle here, this is 30, this is 30. I know that this is a right angle. I still know that this is h, but what is the length? Like imagine this would be where that 60 would be. So from here to here is x, and from here to here is 30. That's 30 feet. So I can also use kind of the same setup, and I can conclude that on this situation, right, I can say that the tangent of 30, and I can put this here, the tangent of 30 is equal to h over x plus 30, because that is the length of this whole side here. So at some point we're going to need to kind of say, all right, well, they both have an h, they both have an x, however x is in the denominator, so I could probably solve for h, right? And I can find the height, and if I solve for x, then I can go back, plug in x, and find for h. So how would I go about doing that? Well, the old algebra, right? I just multiply both sides, I have h by itself. So I have, for this one, I can say that x times the tangent of 60 is the height, since we want to find the height. And over here on this side, I can multiply both sides by x plus 30. It can be tricky because this is a tangent of 30 and this is 30 here. So just realize that anything, right, those would cancel out. So then I can redistribute the tangent of 30 to both of these. So I can say that if I distribute the tangent of 30 to both of these, I could say x times the tangent of 30 plus this 30 times the tangent of 30 will equal, well, h, right? And since this equals h and this equals h, then we can set this right here equal to this right here. Since they both equal h, they must equal each other. So I'm going to rearrange that just so we see it. So I'll draw kind of this line to begin doing it. I can't just drag and drop. It would be nice if I could. But x times the tangent of 30 plus 30 times the tangent of 30. Okay, and so I just wrote this right here, but then I'm going to write equals x times the tangent of 60. All right, so here we see where I have a lot of maybe stuff that could look a little tricky here, but what do I notice? If I want to solve for a variable, the variable's got to be on the same side. So I'm going to move this tangent of 30 to the other side. So how do I do that? I just subtract it from both sides. So I'm not going to kind of do it in this step. I'll go back and do it after, just because then sometimes visually this helps. So I have x times the tangent of 60, and then I'm going to minus x times the tangent of 30, so you can kind of see what I'm doing. So look, I just took this from this side, right? I subtracted it. Again, this is just the basics of algebra in terms of what you do to one side, you do to the other in a very more advanced situation. So you can see the principles that you learned back in 6th grade still carry through to proper procedure later on. So that's why you have to practice. You don't get this stuff down if you don't. But here's another algebraic process, right? X is in both of these, so I can factor out x, and I'm left with the tangent of 60 minus the tangent of 30. Notice I factor out common factors. Again, these are the big ideas that you come across throughout algebra implemented into some geometric problems. Now, this is still algebraic in process, but how do I go about solving this? Well, I just divide both sides by the tangent of 60 minus the tangent of 30. And that goes on this side, right? The tangent of 60 minus the tangent of 30. Okay, so now I have them both, and this would cancel out on this side, and I'm just left with x. And so now I know what's in this box is the value of x. And I know that h, this equation up here that we already found, right, and I'm going to rewrite it over here, we have this x times the tangent of 60 equals the height. So I can replace x with all of this, right? And this is something we can do on our calculator, but I'm going to rewrite it so that we have that in. And this is maybe gets a little messy, so I'm going to try and slide this up just to give myself some more space. And then I'm going to take this and I'm just going to rewrite it. So I'm going to say 30 times the tangent of 30 over, so that's what this is. This box right here is going right here. The tangent of 60 minus the tangent of 30. And I'm going to just put this in brackets just so we see, right? That's what this is right here. I just plugged all of this in for x, so that means this is times the tangent of 60. And that will give me my value h. Now, depending on the calculator you use for this, right, can be a little tricky. So I'm going to pull a calculator over here just to kind of help you see how you might want to think about it. Okay, so how do I go about calculating this exactly without error? So first things first, in your calculator, make sure it says degrees. Just show you have a couple different things. You can have the radians, you can have the gradient, and then you can have degrees. We want it in degrees just to calculate correctly. So we start with the numerator, and so we have 30 and that's this, tan. And then we're going to multiply it by 30. That's what's in the numerator, right? And so we get this value. So we want to divide it, because that's what the fraction bar says, but we want to group the denominator, so we have parentheses. So if we use that, it groups it much nicer, and then so I have 60 tan minus 30 tan, again tan is tangent, and that equals, so 15. So 30 times the tangent of 30 divided by tangent of 60 minus the tangent of 30 is 15. Now, what do I do next? I have to multiply this by the tangent of 60, or 60 tan. And that gets me to 25.98. So let's just round it to 26. We'll round to the nearest foot. So the height of the pole is not 30 feet, even though that's, I'm sorry, it's not 26 feet, even though this says, I don't know why I wrote 30. It's 26, because I was rounding in my head. So the height is not 26, close to 26, h is 26, right? And so we got to realize that the height is from the eye level to here, up here. So if I kind of look at it, I can say, well, then the real height of the pole's height is equal to 26 plus 6, or 32. And that would be the height of this flagpole, 32 feet. Now, let's take a look at another technique that we can use to solve this exact same problem, which might be faster, okay? And it's only faster if you learned your special right triangle principle. So let's just move this off to the side for a second. And remember this number, 25.98, and then 32. So we should get the same answer using the same process, or this other process. So first, as we look at this, we can see that this is 60 degrees, which means that this is 120 degrees. Well, why is that useful? Because if this is 120 degrees and this is 30 degrees, well, then this is 30 degrees. Well, that makes, these are the base angles of this triangle, which makes it isosceles, which makes this and this equal to each other. So this is also 30 feet. So if I take this triangle, which is this triangle right here, and I'm going to kind of, this is going to get messy, so I'm going to kind of draw it off to the side real quick. And if I draw it up to the side, you can kind of see, and this isn't going to be perfect, but you can kind of see that I'm just doing a sketch, and almost always do we deal with right triangles and when we're dealing with this at the beginning stages, but there are ways to manage things without right triangles. You'll learn those. So this is 60 degrees. This right here is 30. Well, I'm not going to go deeply into this, but you should remember the 30, 60, 90 rule, where 1, 2, square roots of 3, and if you don't remember that, you can go back and watch one of the videos on it. So if this is 30, right, this angle, this is 30 degrees up here. If this hypotenuse is 30, which is opposite the long side, the short side is half of it, because that's the ratio. So this is 15, and the long side is this, the short side, right? That would be 1 times the square root of 3. So this would be 15 times the square root of 3. So if I use my calculator, I should get that 25.98, right? When I multiply, I'll pull this over here just so we see. I should get that 25.98, 15 times 3 square roots, 25.98. It's the exact same answer as what I got way, way, way down when we looked at the problem before, way down here. Now what's nice about that is the difference again is I have to add the 6 feet, this distance here, right? So this is plus 6. So I'm still going to get that same answer. I'm going to say 25.98 plus 6, or we'll get 232 is the height of the pole. All right, and that's two different ways to evaluate a kind of a complex trig problem. This is not simple, but if you can do this, you've got a pretty good handle on a lot of difficulties with it.